Hey guys, this is Note Video 5.5, VSEPR Theory and Drawing. This is going to take the next step from drawing covalent bonds and start to assign the shape of the molecule. So this is where we will really start to make sure our final structures are drawn correctly based on this thing called VSEPR, which we'll talk about in just a second. So let's dive right in. We're going to be on page 17 in your notes. Okay, so if you have questions and you want more practice with drawing covalent bonds, because I know that there's a lot going on with those, you're going to get more practice with that here. Okay, so this thing called VSEPR, all right, what that stands for is valence shell electron pair repulsion. Okay. So if you look at the first letters, there's the acronym that you get. Now it's called VSEPR, that's how it's pronounced, even though it's like spelled VSEPR. Okay, I get that. It's just easier to say VSEPR. But basically, guys, if you take a look at that, valence shell, outermost shell, electrons, again, those valence ones are the ones we're looking at. And it's talking about pair repulsion. So basically what this is saying is that electrons, they have the same charge. They're all negative. They want to repel each other. Like charges will repel. Opposites attract, okay? So that repulsion that all atoms are experiencing is going to force them to kind of move and be shaped in certain ways. And that's what this chart right here is really describing. So you can see you've got a picture of the molecular shape. This is kind of a little formula that's going to help you remember the type of molecule and the shape that goes along with it. And it tells you how many atoms are bonded to the central atom and then how many lone pairs are also. So make sure you know the difference between an atom being bonded and a lone pair of electrons. Okay? So you need to memorize, which means you need to study and know the first 6 for this class. So linear all the way down to the second bent. Okay, so if you wanted to draw a line right here, okay, these trigonal bipyramidal and octahedral, we won't see those at all in this class. It's more of an AP level structure. But these top 6 are fair game. You need to make sure you know those. The best thing you can do is flashcards, okay? And to make those flashcards, on one side I would write, the name of the structure, and then I would draw the picture as best you can on the other side with the formula to kind of help you know what they are and be able to recognize those in the shapes, because you will see at least one question on the Regents dealing with the shapes, okay? So the first one is linear, straight line, where you've got 3 molecules and they are just kind of, again, in a straight line. The first bent, okay, you can see you've got an atom here, in the central atom. Whenever you see these balloons like this, that represents a lone pair of electrons. And these are the pieces that are really going to force the issue in terms of shape more than anything else. Those lone pairs have a lot of say in pushing everything away, because it's a high concentration of electrons, so it takes a lot of energy to keep those together because they are both negative. They want to repel each other. So that lone pair will kind of dictate the shapes more than anything else. Okay, and then its formula, which we'll talk about how we use the formula in a couple minutes, is AB2E. Trigonal planar, all right, so it looks like a triangle. That's the way I kind of remember that. Tetrahedral is 3 dimensions, so it's like a pyramid, which I cannot draw. I'll try, but it's not going to look very good. Something like that, okay? So it's a pyramid that you've got going on. But notice that it's got 4 atoms around it. There's no lone pairs. Trigonal planar also has electrons around it. With trigonal planar, you might see an exception to the octet rule on the central atom. All right. The central atom sometimes in trigonal planar, one I'm thinking of in particular is BH3, boron trihydride. That would probably be the one you would see. Boron will only have 6 electrons here. So remember, they're trying to get to octet, but there's always some exceptions to the rule. So just be aware. Just go through your method as we did before. If you see BH3, boron will only have 6 there. So I wanted to just let you guys know that one. Trigonal pyramidal, similar to tetrahedral, except it's only got 3 atoms bonded to the central one, and then it's got this lone pair guy right here that kind of pushes everything down. In class, I will have 3-dimensional models so you guys can kind of visually see them in real space. So ask me about that. Okay, I can show you what they all. I'll have them out on one of the counters, and I can so you guys can see what they look like. And then we've got our second bent molecule that differs from the first one because now there's 4 pieces, 4 entities around the central atom. We've got 2 atoms that I just circled, and then we've got 2 lone pairs. Okay, so it's similar but different. Again, look at the formulas and kind of what it is. B just represents an atom that's bonded. E represents those lone pairs. So let's just jump in and do some more practice and kind of see how we use those. Okay, so VSEPR, like we said, valence shell electron pair repulsion, it's a way to predict, okay? It's predicting the best we can the shape of what a molecule actually will look like. There's a repulsion. That's what's driving it all, is this repelling of those negative charges, okay? So first thing you're going to do is you're going to draw the Lewis structure, which is what we were doing in the last video with the covalent bonds. Once we have that structure, kind of a crude drawing, we're going to make sure the final one actually reflects the shape from now on. Okay, so from this point forward, your final answer has got to reflect the shape of VSEPR. Okay, so to do that, we're going to put in ABE form, where A represents the central atom, B represents atoms that are bonded to A, Y is just the number of those, E represents lone pairs. You'll see what kind of how I do that here, excuse me, in just a minute. And then we're going to tell what the shape is and make sure our final drawing reflects that shape. So here we go. Let's just do an example together. We've got SF2. So same thing. I'm going to, as we were doing in the last video, I got to figure out what my number of valence electrons are. So sulfur's got 6, plus we have 2 fluorines, which have 7 valence electrons each. So 14 plus 6, I have 20 electrons that I've got to account for. Now I'm going to do my work right here to kind of start it because I want to give myself plenty of space over here for my final drawing and kind of thinking about what's going on. So figure out your central atom. It's going to be the first one again. So we've got sulfur as our central atom here. And I'm just going to put my 2 fluorines around it like I was doing in the last video. I'm going to connect them with bonds. Always start with single bonds first. So I'm going to subtract out 4 bonding electrons. BE is just bonding electrons here just to save some space. So I've got 16 other electrons that I've got to account for. So start with the outer ones, 2, 4, 6, 8, 10, 12. Okay. Sulfur needs 4 more as well, and that's going to be my other 16. Okay, so subtract those out. I used all my 16. Boom. Sulfur difluoride. Now, we've got to, in the last video, this is where we would stop. Okay, we'd be like, okay, there's my structure. Now we've got to take it that step further. We got to figure out what the actual shape is going to be, and then we will make sure that our final drawing actually reflects that. So what I'm going to do is use a different color to kind of show you this process of putting it in this ABE form. Okay, so what I'm going to do is actually draw over the atoms and the lone pairs, those letters. So A, according to what my little rules here show, is my central atom. Okay, so there's that. B represents atoms that are bonded to A. So every spot that I see an atom bonded to A, I'm going to write a B over it. So there's a B, and there's a B. Okay. Then E represents lone pair electrons that are on A. Notice, it's not the lone pairs that are on your atoms, okay, your satellite atoms, the ones that are hanging attached to the central one. It goes back to the central atom. If you start putting E's around here, it's going to be crazy and you're not going to find the right shape. The shape is always in retrospect of the central atom. So make sure that you're looking at the central atom here with this. So I've got a lone pair right here. There's one E. And I got a lone pair right here. That's another E. Okay? So now I'm going to just write my formula. I've got A. How many B's do I have? I've got 2. How many E's do I have? I've got 2 as well. So now I'm going to go back to my last page, and I'm going to figure out, okay, what formula, what molecule has the formula of AB2E2? And if I look, that's this guy right here. So this is a bent molecule. It just so happened that our original one actually showed that bent shape. But we're going to redraw it because we wrote over it. So my final answer here is going to be S. I've got my 2 fluorines. Remember, make sure you show all the lone pair electrons. Okay, the Regents exam will say, draw the Lewis structure showing all the electrons. If you don't show all those electrons, okay, you won't get credit for it. So this is what my final structure actually would look like. So it just happened that it worked out that way, that my original one was the same as what the final one. It's not always going to be that way. You may have to make adjustments, so make sure you are aware of that. Okay? So is it anything brand new? It's one extra step from what we were doing with the last video. So let's do example number 2 together. If you feel confident, pause the video now. Try example 2 in the you try problem on your own, and then hit play, and then come back and see if you got it right or not. So carbon has got 4. I've got 4 bromines that have 7 valence electrons each, so that gives me a total of 32 electrons that I've got to keep track of. So again, start with it. Central atom is going to be C, Br, 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 Br. Connect those for my skeleton structure. So I'm going to subtract 2, 4, 6, 8. So 32 minus 8 is going to give me 24 other electrons. Well, that's going to be taken up with all these bromines because they all need 6 more. You can see it's probably getting faster the more you do to draw those structures. Okay, hopefully it is. That's where we're trying to get to. Now let's figure out what the formula would be. You might already know this one, be able to see it. The more you do, the more you'll be able to see what the structure is. So, this formula, this ABE formula, maybe you need it early on and you won't need it later on. That's great. But just find the way that works for you. Make sure you know those first 8 that were on that table before. So, here's my A. This is a B. This is a B. This is a B. This is a B. Do I have any lone pairs? Nope. I have 4 things bonded, so this is going to be AB4. If I go back and look on my chart, what one has AB4? Oh, that's a tetrahedral molecule. One thing I forgot to add up here, guys, this is a bent molecule, so make sure you put the shape with it. So I'm going to redraw it because I wrote over it all. Okay, it's going to look like this. Remember, make sure that you show all of your lone pair electrons. Okay, and I'm going to write tetrahedral. Okay, so if you got that, great. If you went with it with me, then try this one on your own. Here we go. Oh, notice we've got a charge here. That's going to help. That's going to be something we have to do and think about when we count our electrons. Sulfur's got 6. 3 oxygens are going to bring 6 each. Now, what do we do with a negative charge? We add that to our total number of electrons, not subtract it. So 6 plus 18 is 24. We've got 26 total electrons that we're going to be using here. So let's just jump right in. I'm going to kind of spread out my oxygens. I'm going to connect them all with a bond. Subtract that. I've got 20 more electrons that I've got to use. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. Okay, so there's 2, 4, 6, 8, 10, 12, 14, 16, 18, and then I need 2 more, which, oh look, sulfur needs it, so it looks just like that. Now, is my structure done at this point? No. Okay, remember, with an ion, this thing called a polyatomic ion, you have to have the brackets and you have to have the charge. If you don't have those, you will not receive credit. Now, we got to figure out what this shape looks like so we can draw the final shape to reflect that. Okay, so I've got my A here, so I know it's going to be A something. Here's a B, here's a B, here's a B, so I've got B3. And then look, I've got this lone pair, so that's an E. So AB3E is what my formula is going to be. Oh, look, this is that trigonal pyramidal. So notice, if you look at the 3D model in person, guys, these 3 down here are actually sitting below the central atom. So we need to draw that as best we can. I realize we're trying to draw 3D on 2 dimensions, so it's a little bit challenging. Do the best you can with it. So how I would draw this is I would have my sulfur in the middle, and I would kind of draw my oxygens to be sort of down below. and I'd have my lone pairs up here on the sulfur, and then make sure I have all my dots on the oxygens. One thing you might see sometimes is lines to represent those lone pairs. Okay, I have weighted to kind of show you that, so whatever you feel comfortable with, if you want to draw the lines, like the dashes representing those, that's fine as well. But just make sure that you show all of those. And then since this is a polyatomic, we've got to have our brackets with our charge, and then explain or tell what shape this is. And this is trigonal pyramidal. So my challenge for you would be to go back to your previous homework page from back here that you guys did after the last video and figure out what the shapes are. This is just some good extra practice, and redraw those shapes to reflect that. If you have questions, let me know. And then also you can go on and do this practice sheet as well. Okay? If you have questions, come talk to me.